If k of x equals 1/3 times 3x minus 1 squared plus 4, write the function in standard form based on the following transformations. We can see originally that k of x had some transformations already done to our original quadratic function. We've got a vertical stretch of 1/3, we have a horizontal stretch of 3, we're moving it to the right 1 unit, and it was moved up 4. So we're going to do more transformations on top of what was already done to our original quadratic equation. We would like to reflect it over the y-axis, move it to the right 2 units, and up 4 units. So again, as we look at these, we want to think about, are they input changes or output changes? Reflecting something over the y-axis is an input change. Moving it right 2 units is also an input change. Moving it up 4 units is an output change. We would like to write an expression for k of x to think about those transformations so we can apply it to our function and get the new equation. So again, we're talking about those input changes, right? Reflecting it over the y-axis is taking the opposite of your inputs, moving it to the right 2 units, and moving it up 4 units. So you can see this is how our input is changing. So we're going to take these transformations and put them into our function for k of x. We also are moving it up 4 units. We're going to put that into the function here for k of x. So we have the transformations put into our original function, and it looks like so. At this point, we need to follow our order of operations to simplify the equation and put it into standard form. So we got to multiply things out, combine like terms, and see what we're working with. So the first thing I would suggest is simplifying what we have inside our parentheses, so distributing the 3. And then we can see that we have some like terms again with our constants and combining those. And so we've got 1/3 times our quantity negative 3x minus 7 squared plus 8. At this point, we should take care of our power, so our squaring. So you might want to write out your parentheses twice to make sure you're multiplying them correctly by distributing. And so if we distribute a negative 3x and a negative 3x, that would be 9x squared. A negative 3x times a negative 7, that's a positive 21x. A negative 7 times a negative 3x, that's a positive 21x. Negative 7 times negative 7, that's a positive 49. Again here, after we distribute, we want to say, do we have any like terms? And we do have some x's, some linears we can put together. And we're getting closer to putting it to standard form. At this point, we need to multiply everything by 1/3. So if we do that, we'll have 3x squared plus 14x plus 49/3 plus 8. Almost in standard form, except we have to combine our constants. So this is in thirds, we can put this into thirds. Remember, you're multiplying 3 over 3, you're 8 over 1. So we're going to get 24/3. So by adding those two terms together, we'll have the standard form for our function. So we would have 3x squared plus 14x plus 73/3.